Hello Calculus 12. This is the optional video on the proof of the rule, or the limit I should say, that the limit as x approaches 0 of sine x over x is 1. So we're going to prove that. And the proof of this is going to be something called the squeeze theorem or the sandwich theorem, which is kind of a neat one, which you'll see in a minute here. I've taken the liberties of drawing kind of a geometrical, this is a geometric proof of why this is true. So bear with me. What I have is two concentric circles, an outer circle here that I'm going to have a radius of 1 just for convenience. Then I've drawn an angle on top of that bigger circle, and it happened to hit here at some point A that I called xy. And if I drew a perpendicular line down, I drew another circle there concentric to the outer circle, which is inside the bigger circle here. And I called that point B, I called the origin O, I called this point here of that circle C, and I called the point there D, and this is A. So here are some facts. First of all, we're going to, because we're approaching an angle that is approaching 0, we're going to assume the angle is between 0 and 90, so we're going to assume we're in quadrant 1, and this angle is getting smaller and smaller and smaller and smaller. An area of a sector. A sector is basically a pi wedge. So when you're dealing with that particular situation, if I was, we'll come to that in a minute, for example, here's a pi wedge right there, that would be a sector. And the area of a sector, just so you're aware, which you might not know, is 1/2 the radius squared times theta. You can prove that as well with kind of ratios. I also need the area of a triangle, which is, you should know, 1/2 base times height. Also, for the big circle here with the radius of 1, if I was to do the right angle, because there's a right angle right here in that triangle, sine theta would equal opposite y over hypotenuse, which is 1. So basically, sine theta equals y. And cos theta would equal adjacent x over hypotenuse 1, x over 1, hence cosine theta would equal x. So that's kind of the facts or the formulas that are needed to prove this. And here's what the squeeze theorem says. So the geometrical thought would be this sector angle here of OBD, what I've shaded in here, is going to be less than or equal to, and it would be equal to if this was squished down to 0, but right now it is definitely, this is smaller than the triangle OAB. So the triangle would be in here. And I think we can see that. This wedge is definitely smaller than that wedge, which in turn is smaller than the big sector of this entire wedge shape here, sector OAC. All right, so I think geometrically in quadrant number 1, this fact is definitely true. So you'd have to believe that. So that's the only trouble with a proof. If you don't believe that, well, the whole proof falls apart. I do believe that. I can't argue any differently with you there. I agree. If I had a garden that was drawn like this, yeah, this is smaller than that, which is smaller than the whole wedge. Got it. Area of sector OBD, so it's a sector, is 1/2 radius squared times theta. So it's 1/2 times the radius. The radius of this triangle, or this circle here, or wedge, is x. So it'll be 1/2 x squared times theta, which is theta, is less than or equal to the area of triangle OAB. Well, the area of a triangle is 1/2 the base x times the height y, which is less than or equal to the entire sector, which is 1/2 radius squared. The radius is 1 times theta. So this initial statement makes sense geometrically. There's the formulas being laid out. Now I'm going to replace x's with cos theta and y's with sine thetas. So you end up with 1/2 times cos theta squared times theta is less than or equal to 1/2 cos theta times sine theta, x times y, which is less than or equal to 1/2 times theta. So far so good. All right, remember we're trying to get to this here. We're trying to get to a Again, I'll write this in theta form. Limit as theta approaches 0 of sine theta over theta. So we're trying to get to a sine theta over theta situation here. So first thing that I'm going to do is just be creative with my, I guess, your algebra in a sense. And I am going to, because I'd love this middle term to be a sine theta over theta. So I'm going to divide this by a half to get rid of the half. I'm going to divide by cos theta to get rid of the cos. And I'm going to divide by a theta so I can get my sine theta over theta. But now I need to do that to all sides. Now I've got to be careful here. When I divide in a proof, this could give me kind of a paradox situation. But is this valid? If theta is between 0 and 90 degrees, these are all positive values, so there's no inequality issue, so this is still true algebraically. And theta is not really 0. I'm going to assume it's a little bit bigger than 0 at the moment, okay? Because remember, we're doing a limit. I'm not 0, because if this was 0, this would be false. I'm dividing by 0. So watch what happens. This center of the inequality becomes what I am trying to address. This halves divide out, thetas divide out, and you get 1 over cos theta left over. Here the halves divide out, the thetas divide out, one of the coses divide out, and you're left with cos. So this was true, this was true, this was true, this has to be true. Now, what happens when I make theta approach 0? This is what I don't know, but the limit of this must be between the limit of this as theta approaches 0 and the limit as this approaches 0. And what's cos theta as theta approaches 0? That's cos of 0. This I still don't know. This is what I'm trying to work with. And you'll see why this is really neat and why it's called the squeeze theorem. Plug 0 into this. Cos of 0 is 1. So it's 1 over 1. That's 1. And look at what we get. This is kind of a remarkable thing. We've just shown that this middle term is bigger than this, smaller than that. But on the smaller side it's 1, on the bigger side it's 1. By sheer just squeezing, we know that this has to be, there's no other value for it. It has to equal 1. Because on the lower end it's 1, on the higher end it's 1. So therefore, by the squeeze theorem, that has to be 1. Okay, so there's the proof. Now you can use it with great confidence. So that's just a geometrical proof. Like to shake the hand of the person that came up with that. It wasn't me. I just learned from other dead people. Okay, have a good day. And hopefully we'll see each other sooner than later. Good day.